Okay, in this IB differentiation question, we're going to have to do a little bit more algebra. We can't use our calculator as much because of the way it asks us to do the question. So let's look at the wording that tells us that. So we've got these standard formulae: v equals pi r squared h and a equals 2 pi r squared plus 2 pi r h. We're going to use these to show that for a cylinder with a equals 200, that v will equal this. So let's start off doing part 1. And we've got a, which is 200, equals 2 pi r squared plus 2 pi r h. Now what you'll see is in this volume formula, there is no h. Okay, so we need to get h in terms of r, so we can get rid of the h from the v formula. So if we do 2 pi r h is equal to 200 minus 2 pi r squared, and then we're going to divide throughout by 2 pi r. 200 divided by 2 pi r is this, minus 2 pi r squared over 2 pi r. And we can see we can cancel a bit of this down, and we can cancel quite a bit of this down. And what we get for h is we get 100 over pi r minus r. Now we know that v equals pi r squared h. If we substitute 1 into 2, okay, what we get is we're going to put all of this in for h. So we get v equals pi r squared times 100 over pi r minus r. So therefore, when we multiply this out, this pi is going to cancel this pi. One of the r's here cancels r, so we get 100r. Pi r squared times minus r gives me pi r cubed. All right, for part 2, we want to find dv by dr and d2 dv by dr. So let's just scroll down a little bit and do that. So dv by dr will equal, sorry, let's do it over here. It makes more sense and rub this out. Equals, differentiate with respect to r, we get 100. Differentiate this, we get minus 3 pi r squared. And d2v by dr squared, 100 goes to 0, so we just get minus 6 pi r. Part 3. Now, it does say use calculus to find the value of r that gives the maximum value for v, so we've got to use this. So we know at this point that dv by dr equals 0. So we know that 0 would equal 100 minus 3 pi r squared. So therefore, r squared will equal 100 over 3 pi, and r will equal the square root of that at this point. We can get plus or minus, but you can't have a negative r, so therefore it's going to be the plus 1. Use calculus to find the value of r that gives the maximum value for v, and hence find this maximum value. So we've got to find the maximum value. So we put this result back into the formula for v here. So we've got 100 times by the square root of 100, square root of 100 over 3 pi, minus pi times square root of 100 over 3 pi. And we got that cubed. Now what we can do is we can check this on our calculator. If we go into menu 5, we can see I've already written in, actually what I've done is I've written in the, no, I haven't written in the right one. Let's just go right to it. So we get 100 r minus pi. It should be x cubed. Okay, 100 r minus pi. There we go. Let's press execute. Let's draw that. And we can see it goes off the scale, but it doesn't matter because it's clearly gone up and come down. So therefore, there must be in our domain. We can just press graph solve and get it to find the maximum value. And it tells us that x equals, or our r in this case, is 3.26. And our v, if we were to work this all out, equals 217 to 3SF. And if you work these two things out, you will see that they are equal to these two values. So you can always check your answers to make sure they are right.